Hi guys, you're welcome to Halogenous Ideas. So in this video we're going to be talking about the history, it should be the history and development of computers and their generations. So before we move any further, we'll be talking about what a computer is. So basically a computer can be referred to as an electronic machine that will accept data first. Then after accepting data, it will process the data. Then after processing the data, it will give out some sort of information that is going to be used by the user in one way or the other. So don't forget, three things are supposed to be ringing in your head right now: input, process, and output. So there must be means to collect data, there must be means to process data, and there must be means to show output. Okay, so look at the definition I have here. A computer is an electronic device that processes data to perform various tasks. So the various tasks that are going to be performed depends on the computer that we are talking about. For example, if it's an addition machine, you know that the task to be done is just to look for the sum of numbers. But if it is if it's a subtraction machine, then we want to look for the difference between numeric data, two different numeric data. So it can handle a wide range of operations, from simple calculation to complex tasks like running an application, managing databases, and controlling machinery. Computers are versatile and can be programmed to execute a diverse set of functions, making them integral to modern life. One of the reasons why we call it modern technology is actually because computer got involved. If it is saving us time, it is saving us energy, it is saving us resources, and most importantly, we are not compromising quality. So we are going to be moving on to the stored program concept. Okay, so this is one of the major reasons why a computer differ from so many other type of machines that were invented. Okay, the stored program concept is a fundamental idea in computer science that describes the storage of both data and instruction in a computer's memory. Both data and instructions stored in the same computer's memory. In a computer system, programs which are sets of instructions and data which is basically the operand that this instruction are going to be performed on are stored in the same memory, and the computer's processor fetches and executes these instructions sequentially. Okay, so two things now. The programs which are set of instructions and the data stored in the same memory, the computer's processor will fetch this data and execute this set of instructions on this data. Okay, so these instructions are going to be executed sequentially meaning that if you have instructions lined up 1 2 3 4 5 6 7 8 9 and 10, it will execute instruction 1 first, then it will go to 2, it will go to 3, it will go to 4, then till it gets to 10. This concept was first articulated by John von Neumann, a Hungarian mathematician and a physicist. So in the stored program architecture, instructions are represented as binary code, and binary codes are basically zeros and ones, zeros and ones. So an example of a binary is something like 0 1 1 0 1 0 1, something like that, something like this. This is what a binary will look like, just zeros and ones. That is what a binary looks like. Okay, so this allows for as binary code and stored alongside the data in the computer's memory. Don't forget, in the stored program concept, the programs which are set of instructions and the data are stored in the same memory. Very important. So are represented as binary code and stored alongside the data in the computer's memory. This allows for flexibility because different programs can be loaded into the memory for execution, making it possible to perform a wide variety of tasks without physically altering the computer's hardware. So you can store all these instructions sequentially together with the data. The computer knows that since these instructions are going to be executed sequentially, you can just the first task put it on the at maybe line 1, the second task put it on line 2, the third task put it on line 3, and like that. So you just program it into the computer. When the computer is done executing the first one, it goes to the second one. When it's done with the second one, it goes for the third one. So, and that is how it will execute all the instructions sequentially. Okay, so This is one of the major differences between the computer and other processing machines, the stored program concept. Okay, so let's move on to hardware and software. So hardware, this refers to the physical components of a computer system. Okay, it includes the central processing unit, which is this CPU, the central processing unit, the memory, which is the RAM, the input devices, output devices, and other peripherals. Hardware is responsible for executing instructions and manipulating data. Okay, hardware is responsible for executing instructions and manipulating data. Your mouse, your keyboard, your monitor, your printer, your joystick, your light pen, any physical component of a computer system is classified under hardware. Okay, so we move on to software now. Software encompasses the programs and data that instruct the computer on how to perform certain tasks. So the programs and the data is what you refer to as the software. For example, this I'm using Google Docs for the presentation. So Google Docs, this is basically a software program that I can use to write for word processing, basically Google Docs for word processing. We have so many of them on a Windows machine. For example, if you come here, I have Node.js, I have Winra. These are softwares. I have Telegram. If you come to the Microsoft, okay, everything is scattered over here. C shortcut I use for video editing, the Skype, the OneNote for Windows 10, a lot of things that you can do, the different softwares that are available to perform different tasks. So the software includes the operating system, includes the application, the utilities, and other program. A good example of a utility is this notepad that I have over here. Another utility might be a lot of utilities available. The OneNote, the Skype, a lot of them, a lot of different utilities. We also have the calculator. If you come the calculator, okay, so if you can see my standard calculator over here. So I think we have the scientific calculator too that you can use to do a lot of other things. You can expand your calculator, and so this is another utility software. Okay, so and other programs. Software provide the logical instructions that the hardware follows to carry out various instructions. Don't forget, if you come to this stored program concept, we have programs and data stored in the memory. Okay, the computer's processor fetches what? Data, and executes the instruction sequentially. So basically, these are softwares. The program, which are the set of instructions, and the data can be classified under software. Now it is the hardware that will be used to execute the instructions. These instructions, this is the hardware that we will use to execute the instructions on the data. Okay, so where was I? Okay, so the relationship between the hardware and the software. So execution of instructions, the CPU, which is a key hardware component, fetches, decodes, and executes instructions stored in the memory. These instructions are part of the software, forming the basis for the computer's operation. Okay, so basically the CPU, which is the central processing unit, is a hardware component that is going to be fetching this data. Where is the data? It will fetch, you can see the central processor, which is the CPU, fetches this data, the instructions, and executes the instructions on this data. But hardware is what does the execution. Okay, it is the central processing unit that fetches and executes these instructions. So fetches the codes and executes instructions stored in memory. These instructions are part of software, forming the basis for the computer's operation. So we also have interaction. Input devices, which are hardware, allow users to enter data, okay, which is then processed by software. The results are presented through output devices. These output devices are also hardwares. Okay, so then we have the flexibility. The stored program concepts allow for separation of hardware and software. So this separation facilitates flexibility, as different software programs can run on the same hardware. Upgrading or changing software doesn't necessarily require modifying the hardware. In some cases, it might require modifying the hardware. For example, You might want to install Adobe Premiere on your laptop, and your laptop is say a 2 gig RAM laptop. Obviously, Adobe Premiere, your laptop will not be able to carry it, so you have to upgrade your hardware. But it is not always like that. If you want to run a software like Google Chrome on your laptop, I believe that every laptop can run Google Chrome. So basically, you have the software. Changing it doesn't necessarily require modifying the hardware. Okay, so we have the control and coordination. The operating system, which is a crucial software component, manages and controls the hardware resources. Like I said the other time, the operating system stands as an intermediary between you, the user, and the computer. So, and the computer hardware. Okay, so ensuring efficient execution of programs and proper interaction with peripheral devices. It is anytime you want to use an external device together with your computer, your computer needs to drive that device. It is your operating system that has those drivers that will drive the device to know that, okay, this device that entered at the so USB port is a mouse. This other device is a flash drive. This device is a joystick. This device is a writing tab, and so many other things that you can do. This device is a Bluetooth device. So it is the operating system that drives whatever external device that you try to connect to your computer hardware. Okay, so the operating system. Okay, very good. And proper interaction with peripheral devices. So, in summary, the relationship between hardware and software. All I've been saying since is I'm trying to explain the relationship between hardware and software. So, in summary, the relationship between hardware and software is symbiotic, which with hardware providing the physical means for executing instruction and software providing the logical instruction. Okay, so hardware is bringing the physical means, software is providing the logical instruction that drives the hardware to perform those tasks. So the stored program concept is central to its relationship, enabling the dynamic loading and execution of different programs on a computer system. Okay, so that is all for the stored program concept and the hardware software. Okay, so let's talk about the historical development of computers. So before the age of digital computers, computing and arithmetic operations, whatever addition, subtraction, multiplication, and division that you want to do, you have to do it with some part of the human body, say your fingers and your toes, or you can use objects including sticks, stones, and anything basically that you can use to count. So but if you take a good look at these objects, they are limited in what they can calculate. You cannot use an object to calculate 1 million plus 1 million. No, you can't. So um, these limitations birth the age of computers, basically the age of calculators and computers. So the first computer that we're going to be talking about is the abacus computer. Okay, the abacus counting machine. So this counting machine was said to have originated in 3000 BC. So it consists of beads. You can see the beads over here. It consists of beads sewn on an iron rod, sewn on an iron rod, and each bead above the iron rod stands for 5. Okay, so for example, what I have here is 5, 10, and each bead below the iron rod represents units. Okay, so these are the units. Apart from the abacus computer, we also have the adding machines that Blaise Pascal came up with. Okay, so Blaise Pascal, a French teenager at the time, so he was at the age of 19 when he invented the adding machine, the first adding machine. So the Pascal adding machine was built to reduce the numerical labor put into his father's work for the French crown as a supervisor of taxation and public expenditure. So a teenager just looked at the kind of work, how stressful his father's work is. Then he developed a machine that could help his father work more efficiently and with less stress. Okay, so in Pascal's machines, numbers were entered on dials, but the results were read from dial positions. So this is what the Pascal's machine looks like. So between 1663 and 1666, this Englishman built three other machines, one for adding and subtracting pounds, shillings, pence, and fatlings. Then the other two are not particularly used for calculation, but there is one in particular that were used for this function. So in 1671, so this guy, a German philosopher, invented a calculator with sliding gears. So this is what they refer to as the Leibniz machine. Okay, so the stepped Rockner, this could do addition, subtraction, multiplication, and division as well. Okay, so we also have the Charles Babbage machines. So these machines, he developed two machines. The first one is the difference machine. The second one is the analytic machine. So Charles Babbage made the first attempt to design an automatic counting machine different from a hand calculator. So this guy, an Englishman, born in Devonshire in 1792. So he educated at Trinity College, Cambridge. So Babbage developed the difference machine to compute astronomical and navigation tables rapidly and accurately. So they started developing this machine in 1823, but because of government funding, Babbage started thinking of so many other things they could do to augment the project, to make it way more efficient and to make it more sophisticated, and this would require more government funding. So because the government couldn't take on the project, so they didn't fund the project, the idea died. So Babbage went ahead to develop another machine which he called the analytic engine. It's supposed to be powered by a steam engine. Okay, so input was the input, which includes programs with data, was to be entered using punch cards. The output, the output component of the analytic machine consists of a printer, a curve plotter, and also a bell. So the machine would be used to punch data into cards which will be read later. So it's more like you having a flash drive, you put it into your computer, you save some videos, then at a later date you put the flash drive into your computer again, you read your videos, copy it to your computer, and watch it at your own convenience. Okay, so that is exactly what is happening here. The punch cards, let me see if the analytic machine punch cards. Okay, I think this is what the punch card looks like. So the machine is going to punch the numbers into these cards, then at a later date it can read the numbers. So that is it. And the analytic machine calculates in base 10. All the arithmetic operations that are going to be done will be done in base 10. The analytic engines uses the store. The store is like a component of the analytic engine to hold data, while it uses the arithmetic unit or the memory to perform addition, subtraction, multiplication, and division. If you come upstairs, you remember that we use the somewhere around here. So you can see it uses the store, like as in the analytic engine. It uses the memory to store data, but in the case of the analytic engine, they call it a store. Then it has the arithmetic unit. If you come to the arithmetic unit or the memory to perform addition, I think this is supposed to be arithmetic units only. It should be arithmetic units only. Sorry about that. So to perform addition, subtraction, multiplication, and division. Okay, so the analytic engine is quite close in concept to modern computers in terms of general purpose computation, meaning that you can do you can perform a wide range of operations using it. The stored program concept, in which the instruction and the data are stored on the same computer. So we have the control flow and conditional branching, meaning that you can execute certain instructions only if certain events take place or based on certain conditions. So we have the sequential execution, which is basically you executing from the first one to the second one to the third one, then down to the last one. Okay, input and output devices like punch cards for data input and printer for output. Then we have the separate control unit, which is responsible for managing the sequence of operations from the arithmetic unit. So this is the control unit and the arithmetic unit. They are different components, okay? They are separate components. So while the analytic engine was never fully built in Babbage's time, its conceptual contributions have left a lasting impact on the field of computer science. Many of the principles he envisioned in the 19th century are foundational to the design and the operation of modern computers. So basically, that will be all about the historical development of computers and their generation. So, and the generations, we spoke about the what a computer is. We spoke about the stored program concept. We spoke about the hardware and the software. We also spoke about the relationship between the hardware and the software. We spoke about the historical development of computers. We spoke about the abacus, the adding machines, and the Charles Babbage machines, which consist of the difference engine and the analytic engine as well. Okay, so well, that will be all for the historical development of computers and their generations. So don't forget to subscribe to our channel and to like the video. Then don't forget to subscribe to our channel and like the video, and you can support us by sharing with your friends. Don't forget to like the video and to subscribe to our YouTube channel so that when we drop videos like this you get updated. Thank you very much. I'll see you on the next one. Bye for now.